Hey, welcome back to RamZland. Today I want to share with you the single displacement redox reaction between a solution of copper chloride and aluminum using a can of Coke. Check this out. All I'm using in this investigation is a can of Coke, a graduated cylinder with 50 milliliters of distilled water, a beaker with 75 milliliters of distilled water, aluminum foil, copper chloride, this is what your copper chloride looks like, and some sandpaper and a stir rod. The first step is to measure out around 9 grams of copper chloride. Next, add the copper chloride to your solution and stir it until it becomes aqueous. The next step is to sand your Coca-Cola so the part of the can that's exposed to the copper chloride doesn't have any paint on it. This is the classic reaction that most people do between sodium hydroxide and an aluminum can. And I did this several years ago, where the sodium hydroxide starts to eat through the aluminum and you're left with just a plastic liner where you can actually see the Coke inside the can. But this reaction is different because instead of using sodium hydroxide, I'm using copper chloride. Check it out. And now we're ready to lower our Coca-Cola into the beaker, and you'll see that the water displaces nearly to the top. And pretty quickly you'll start to see bubbles form along the top here. And you'll start to see copper displaced on the sides of the can. And the copper chloride will change into aluminum chloride. Okay, let's check to see if some copper has been displaced on the sides of the can. Look at that. Look at all of that copper. You can literally scrape it right off the edges of the can. Let's leave it in there a little longer. Not believe this, but so much of the aluminum reacted that it actually tore through the side of the can. Just look at that. Right through the side of it. You can see all of this copper that was displaced on the outside. And the aluminum changed into aluminum chloride as that copper was displaced. Look at that, look at all that copper. Isn't that just amazing? It split from the top all the way down to the bottom in this awesome reaction. Another way to observe this same reaction is to take a stick of aluminum foil and lower it into a graduated cylinder that has a solution of copper chloride. Let's take a look at that. For this reaction, I'm going to measure out a smaller amount of copper chloride, about 7.5 grams. I'll stir that in my graduated cylinder of 50 mils of distilled water until again it's all dissolved and have a nice, even, aqueous solution. Next, roll up a stick of aluminum foil that's slightly longer than your graduated cylinder and more narrow than the opening of the cylinder. Since this is an exothermic reaction, get a base temperature of your solution. Looks like we're at 74.1 degrees Fahrenheit. Okay, and now you're ready to lower your aluminum stick into your graduated cylinder. Already you can start seeing copper displaced on the outside of the aluminum foil. Just look at all of that copper that's been displaced. That is amazing. Look at that. Isn't that crazy? Very warm to the touch, giving off a lot of heat in this awesome single displacement redox reaction. You can see the temperature has increased. It looks like we're up to about 88.3 degrees Fahrenheit now. Okay, so let's take a look at the equation for this amazing reaction. We start out with reactants aluminum, Al, that's a solid, and copper chloride in an aqueous solution, that's the CuCl2. And when those combine, they create the products copper, Cu, that's a solid that was formed on the outside of the pop can, and aluminum chloride, that's AlCl3, that dissolves into an aqueous solution. I hope you enjoyed today's edition of RamZland, and I'll see you next time. If you enjoyed this presentation, be sure to remember to like and subscribe.